What's up, my COVID-19 social distancing people? What we're also talking about during these notes is we're talking about solving quadratics, but not using quadratic formula, which is also the content for this week, but also solving it using another method by taking a square root of things. Now, this method is going to be a little bit easier to do and less strenuous if the problem really doesn't have a lot of terms in it. Like if you notice you just have an x squared, maybe a constant in there, looking and checking and seeing is if can I easily just get that x squared term by itself. Okay, so if it's really not in standard form, this might be the method that you would prefer. Now, things to keep in mind whenever we're solving this, okay, is properties of multiplication and whenever I square something. Okay, things to keep in mind is whenever I multiply something in a problem, I can't just multiply that one term. I have to multiply the entire problem by something. Same thing with squaring. Okay. Remembering that when I'm multiplying or squaring something, we must apply it to the whole problem. Or every term. We'll say every term. We want to apply that to every single term. And this also goes for whenever I'm trying to do the inverse of these things. So the inverse of multiplication is division. And then the inverse of squaring we'll talk about here today. So in order to isolate the squared term, we want to use really inverse order of operations, kind of what we've basically our basic problem solving strategies. This is just reverse PEMDAS, keeping in mind that we like to get rid of things by subtraction or addition first. Then if we can divide or multiply anything away, usually by that point we want to deal with the exponent and then anything that was in parentheses if there were any. Okay, so it's really just doing reverse order of operations. And solving for the variable. Okay. Now, are there other ways to solve a quadratic function? Yeah, we can use quadratic formula. If you want. So really just looking at this, we're going to go through like different problems of varying difficulty. So in particular, looking at this for this first section of one-step equations, we always want to get the squared term isolated. So ask yourself, what's being squared for problem number one? Hopefully you say the x. The x is the only thing being squared. So we have to ask ourselves using our reverse order of operations, just kind of asking ourselves basic things. Is there anything out other than the squared term on this left side? No. So there's nothing I have to subtract, add, divide, or multiply away. Okay. The x squared term is by itself. So in order to get rid of this squared term, I need to do the inverse of it. So one thing to keep in mind is the inverse of squaring or squaring anything is taking the square root. So what I'm going to do is take everything on this left side and take the square root of it. I'm just going to rewrite it here. Take the square root of the side, which the square root is going to cancel out that power of 2. And keeping in mind, I'm doing the same thing to everything on the right side, which in this case is just 25. So what I'm left with is x, and then I ask myself, what's the square root of 25? You always want to ask yourself, can I simplify that square root to make my life a little bit easier? In this case, I can. The square root of 25 is 5, but what we've got to think about, okay, is adding a new concept to our brain. And that concept that we're going to be talking about, I'm just going to erase this to give myself some more room, is whenever I take a square root, I always want to think about positive and negative solutions. What I mean by that is every time you take a square root, there's not just one answer, there's actually two. Because if you think about it like this, for example, the square root of 25, or just the number 25, you get by multiplying positive 5 and positive 5, which is why a lot of us say the square root of 25 is 5. But also think about if I multiplied negative 5 times negative 5, that would also give me 25 as well. So we can say positive 5 and negative 5 are both answers. So to represent this, I write this little sign called a positive and negative. Okay? Just a shorthand way to represent that solution. Okay, so keeping in mind positive and negative, what this means is it represents both positive and negative solutions. Big thing right there. Every time you take a square root, you've got to write a positive and negative because every square root has a positive and a negative solution. Okay, just things to keep in mind. So you'll see me do that every single time today. And if you've looked at my quadratic formula notes already, or you're going to, you'll notice this sign is in there as well because it means that we have two solutions, always with the square root. Now, looking at numbers 2, 3, and 4, you'll notice all the x squareds are already by themselves, which is convenient. Okay, so I'm really just going to be doing the exact same step in all these problems. But looking at this for example 2, for instance, can I take the square root of a negative number? That's something that we might want to ask ourselves. Hopefully your answer is no, I can't. We really can't do that. So in order to write this answer, we're just going to say that it's impossible because you can't get a negative number by multiplying a positive and a positive or a negative and a negative. So my answer here is just going to be no real solutions. And this is going to be our answer every time we take the square root of a negative number. Okay? Doing things as similarly as I can as if I was in my classroom is that we can't square root a negative. So for number 3, same thing. Let's just go ahead and kind of talk about it. I'm going to zoom in a little bit. I've got x squared equals 162. Square rooting both sides. Now, a nice thing to check is to always ask yourself, can the square root of this number, is it a perfect square? A great way to check that is just type it into a calculator. So in this case, I'll use Desmos, just so we have a visual aid for you guys. Let's go ahead and type this in, start graphing. So we just want to type in the square root of 162. Ew, comes out gross. So I don't want to write my answer as a decimal when solving by square roots. I want to leave it as a simplified value. But now what we've got to think about, okay, is can I simplify this square root? And we've talked about this around November, December time, that when I'm taking the number, I'm just going to write it off to the side, 162, we want to factor this out and find two numbers that multiply into 162. One of them, though, has to be a perfect square so that I can simplify it and basically take this number in the square root and start to break it down a little bit. So hopefully you're kind of thinking about numbers and you can kind of sit there and plug and chug some stuff to see kind of what our values are. You'd have to play with your calculator a little bit. So that the square root of 162 here is going to be the square root of 81 times the square root of 2. So square root of 81 then turns into 9 plus or minus, because it's a square root, times the square root of 2. Now, if you found a smaller number that was a perfect square, you may have to continue to break down the other square root. In this case, the square root of 2 doesn't simplify anymore. Okay, so this is just going to be my answer, is plus or minus 9 times the square root of 2. And these two numbers are the exact same thing as my original problem. Okay. So there we go, right there. Now for number 4, it's a slight difference. Okay. Which 3 is probably as gross of a number as we'll ever deal with. But you guys, being a little number savvy, just sit there and on a calculator, divide 162 by 2, divided by 3, divided by 4, divided by 5. See if you can find the largest perfect square, which hopefully a lot of you guys can identify. So looking at number 4, you have to ask yourself that when I take a square root of both sides, how many numbers are on the right side? Actually 2. So when I take a square root of all of this, what we're really doing is taking a square root of each number of every term, like we talked about. And what's nice about this problem is if I look at the numerator and denominator, hopefully you realize that they're both perfect squares, or they can both be taken a square root of really nicely. So the square root of 6 is plus or minus 4, and the square root of 36 is plus or minus 6. So how I just represent this is saying that my answer, or x, is just plus or minus 4 over 6, which can be simplified to plus or minus 2 over 3. Because 4 over 6 simplifies into a fraction. Okay. So, moving on to the next section, solving a two-step equation. Obviously, looking at this number 5, what's the big difference? The question you want to ask yourself is, what is being squared on this problem? Is the 3 being squared, is the x being squared, or is both? Hopefully your answer is it's just the x. If 3 and x were being squared, it would look something like this, which is not what we're given. Okay. So the x is the only thing being squared here, which means I want to move everything that's not the x out of that side and move it to the other side. So looking at it, how would I move this 3? So you want to ask yourself, what's the 3 doing to the x squared? It's multiplying, so to remove that, the opposite is division, which now gives me x squared equals 9. And now this is a problem that looks something like our prior examples. The x squared is the only thing by itself. So all I have to do now is take the square root of both sides, and noticing, hopefully, that 9 is a perfect square, my answer is just plus or minus 3. So probably you're asking, so is this plus or minus thing going to be on every number that I take a square root of? Answer is yes. Because every time you take a square root of a number, there's a positive solution and a negative, and we want to represent both of those. Okay, because you guys know what a quadratic looks like now, and you notice how it has a U-shaped curve. So for a quadratic, keeping in mind in this case, I would expect that there were 2 solutions at 3 and negative 3. So we have to represent both of those solutions. Okay, so just things to think about there. Now for number 6, once again, what is being squared here? Hopefully you answer the p, not the 12. So getting the p squared by itself, I have to move this 12. And since the 12 is adding, I need to subtract it. Okay. So now I have p squared is equal to 0. Taking a square root of both sides, the square root of 0 is just 0. There is no such thing as negative or positive 0. It's just 0. So this is that special case where there's only one answer. So for number 7, right off the bat, what needs to move here? Hopefully you said the minus 3. So to move a minus 3, I'm going to add it because it's obviously subtracting. And when I do this, I get a squared is equal to negative 1. So hopefully from here, you might notice what I'm going to deal with, because we're dealing with that little issue again. I have a negative in the square root. So looking back at what we've already talked about regarding this, it's going to be no real solutions because I can't take the square root of a negative number. want to be consistent and talk about that. So, looking at number 8, what's being squared here? The 25, the y, or both? I see no parentheses, so hopefully your answer is just the y. So to move the 25, I'm going to divide it because it's multiplying by that. I know it's dividing because there's no addition or subtraction sign in between the 25 or the y. And when a number is touching the variable, just a reminder, that's implied multiplication. So I have y squared is equal to 49 over 25. Now that the y is by itself, this is very similar to number 4. Okay, so we're going to use that as a reference. This goes away. What I noticed, though, is both of these numbers are perfect squares, and I'm going to take the square root of both of them. So what I have here is plus or minus 7 over 5, and that can't be simplified, so that's exactly what my answer is. You could write it as a decimal if you want, like 1.4 plus or minus if you want. It doesn't really matter. Now, I'm going to leave 9, 10, 11, and 12 as a blank option for you guys to kind of practice. If you guys want to print this out or however you want to do it, write on a sheet of paper. If you want to join into my online office hours next week, we can do that. Please feel free to bring those problems and I can talk about those then. But I'm going to leave those for you. Now, for the last 4 examples, which is probably the most difficult problems that we can come across, we're going to be doing both addition and subtraction. Correction, we're going to do multiplication, division, or addition, subtraction at the same time. Okay. So, same thing I always ask. What's being squared in number 13? Is it the 3, the x, or the 11? Hopefully you answer just the x because there's no parentheses bulking it all. So this is the only thing that squared is attached to, which means I've got to move this 3 and I've got to move this 11 using inverse operations. So looking at the 3, how would I move it? Hopefully you think it's multiplying. So what do we do first? Do I move the 3 or do I move the 11? What makes your life easy is if you listen to and kind of just follow that reverse order of operations. So do the subtraction and addition first. Okay. So that always makes my life easy. You can do multiplication division, but then you might end up dealing with weird numbers. So is there anything that I can subtract or add away? Can I erase this? There we go. Yes, I can add an 11 to both sides. So I'm going to take care of that first. So I have 3x squared equals 18 now. And like I said, it's better if you do subtraction or addition because if I had divided both of these, just to show you, because I know some of you might be asking, like, why did he not just divide by 3? Just going to write it over here. If I divided everything by 3, keep in mind I have to divide everything in the problem by 3. You might notice here, like what I usually say in class, I still say here, these are poopy numbers. We don't want to deal with these. I'd rather not deal with a fraction or a decimal versus when I'm working here, I get nice, wholesome numbers that I can deal with. Okay? So dividing isn't, or multiplying isn't necessarily always the best first option. Subtraction and addition usually is. Okay? So just things to think about. So now there's nothing else to add or subtract, but there is something to divide or multiply, in particular divide. And I can divide everything here by 3, which now gives me x squared is equal to 6. So when I take a square root of this, what you'll also notice is that 6 is not a perfect square. But if I sit there And I ask myself, what are factors of 6? It's 3 times 2 and 1 times 6. The only perfect square here is 1. So since 1's the only perfect square, that's a factor of 6, nothing here can be simplified. So my answer, I'm just going to leave as a square root. We don't want to deal with decimals. As plus or minus the square root of 6. So just a note, when simplifying square roots, is that if 1 is the only perfect square, factor, we can't simplify any further. So we just leave it as the square root. Okay, just like fractions, just like 3 over 2. We can't really simplify a fraction of 3 over 2 anymore because 3 and 2 don't have common factors. Same thing with the square root, or really anything that we're factoring, rather. So now, number 14. Ooh, what do you notice is a big difference here? Hopefully you say parentheses. So we've got to think about that now. What's being squared in this problem? The t, the 7, or everything? Hopefully your answer is everything, because the squared is attached to these parentheses, meaning both of these two guys are being squared. So there's nothing outside of it to add or subtract or multiply or divide away, which makes my life simple, meaning I can go right to the getting rid of the exponent stage. So here, to get rid of the squared, I'm just going to take a square root of both sides, just like we've been doing. Okay, so I'm just going to write that down here. T minus 7 squared is equal to 6. So we take a square root of both sides. This goes away. So now when the squared goes away, ask yourself, what's left over here? What have I not slashed out? It's the t minus 7. That stays intact. We've already dealt with square root of 6. We know that that can't be simplified anymore, so I'm going to leave it just like this. Now, what we want to deal with now is anything that was in the parentheses, which is t minus 7. So let's get the variable by itself. What has to move? The minus 7. So to move that, I'm going to add 7 to both sides. And I want to leave these two guys separated. I want to leave the 7 and the square root of 6. I don't want to combine them. Okay, because what we want to keep in mind is the plus or minus the square root of 6 is actually two numbers. Keep that in mind. So we can't just carelessly add 7 to the square root of 6 because it's actually positive square root of 6 and negative, and we want to represent both of those answers. So my answer is just going to be 7 plus or minus the square root of 6. Or if you want to flip that, you can say plus or minus the square root of 6 plus 7. I don't really care. But like we said, we just want to write it as a simplified solution. So this is how we want to leave it. Okay. Usually what you'll see, guys, more is this is the preferred solution. This is what we would how we would prefer to write things, just because the natural tendency is to kind of extend the square root and accidentally bulk it underneath there, okay, which we would like to avoid if possible. Okay. But you get credit for both regardless, as long as you don't make that mistake. Now, if I asked you for a decimal solution for both of them, you could give me both of these answers. Because keep in mind, I'm just going to sidebar before I move on. 7 plus or minus the square root of 6 is actually two answers. It's 7 plus the square root of 6 and 7 minus the square root of 6. And if we wanted to, we could find both of the solutions. But this is a shorthand way of just writing both of those in one. Okay. And if I asked you for the decimal, you could plug those into Desmos and get me both of them. But I'm just asking for the simplified solution. Now, 2 more. So for number 15, same concept, except for hopefully you recognize there's one small difference here. And that's there's a number outside of the parentheses. So what I want is to get this guy by itself because all of that's being squared. So what I need to do is to isolate that and move anything that's not being squared, which is the 4. So I'm going to divide 4 from both sides. So what I'm going to get is I'm going to get m plus 6 squared now is equal to 32 over 4, which is 8. So taking a square root of both sides, we want to ask ourselves, what are factors of 8? So 4 and 2 and 1 and 8. Oh. Are any numbers other than 1 a perfect square? Hopefully you say yes. 4 is. So that's what this guy's going to break down into. 8 is going to break down into, or the square root of 8 rather, is going to break down to the square root of 4 times the square root of 2. And the square root of 4 is a perfect square and turns into plus or minus 2 times the square root of 2. Oh, here we go again. Sorry about that. Which is exactly what I get. So now m plus 6 is equal to plus or minus 2 times the square root of 2. So to get that m by itself, I'm going to subtract 6 from both sides, keeping in mind I'm not going to combine these two items. I'm going to leave them separated. So m is equal to, and I'm going to write this as a preferred solution, negative 6 plus or minus 2 times the square root of 2. Which, like I said, this is actually two answers. It's 6 plus 2 square root of 2 and negative 6 minus 2 times the square root of 2. But I don't want those exact solutions. I just want the simplified, easy solution, which is that. Now, 16 is a good honors problem because there's a lot going on here. And like I said, the first thing we want to do is to identify what's being squared. Hopefully you answer that and say x plus 2 is. So everything I haven't circled on this left side, get rid of it. So let's look at anything that's being added or subtracted first, i.e. this guy. How would I move a minus 10? By adding it. Duh. Okay, my stylus is acting rather weird. So I'm going to add 10 to both sides. So what I'm going to get here is I get x plus 2 squared Let's see if I can fix this. My pen's acting up. All divided by 4 equals 6. So, looking at this now, what I have to do is multiply both sides by 4. So when I do that, I get x plus 2 squared, because I got to multiply both sides by 4 to get rid of this. So like x plus 2 squared is equal to 24. Whew, I was having a little technical difficulty there with my pen. Hopefully that fixes itself. This is going to bother me. I'm going to fix this. Plus 10. Look at that. It looks so much nicer. Okay. So now I'm at a stage where it's actually quite familiar. So hopefully you know what I'm doing next is taking a square root of both sides. And like I said, we've just got to ask ourselves, this square root of 24, factor it. I've got 8 and 3. I've got 6 and 4. I've got 2 and 12. And I've got 1 and 24. What's the largest perfect square? 8's not a perfect square. 3 isn't. 6 isn't. 24 isn't. 12 isn't. Ooh, 4 is. This is my largest perfect square. So this is going to be my pair that I'm going to choose. So this guy breaks down into the square root of 6. I'll start with the perfect square. The square root of 4 times the square root of 6. which then breaks down into plus or minus 2 times the square root of 6. And I can leave square root of 6 there because we've already looked at a problem prior, I believe number 13 and 14, where the square root of 6, we found out, didn't need to be simplified. So I can just leave that as it is. So this guy becomes plus or minus 2 times the square root of 6. So what I have now is equal to x plus 2. So I'm going to subtract 2 from both sides and leave these two terms separated. So what I have is negative 2 plus or minus 2 times the square root of 6. And my answer is that. Okay. So last one was kind of wonky, had some technical difficulties. Hopefully y'all can manage with that. If not, we can always work through that. Okay. So if you have any questions, guys, please make sure that you are emailing me, send me any messages. If I have time and we need to schedule like a conference for like on top of or earlier than Friday, please let me know of that, and I can always see what my schedule allows. But keep in mind, y'all's conferences for honors is every Friday from 12 to 1. That will be a video conference. Links to it are under the module for Unit 10 that you can see. It's relatively simple to get into, and I can answer any problems as a group for that hour. Okay, that's the best way to get interactive help with me on a subject. We can go through adults math problem. That's not a problem. Okay, so make sure you guys do that. If not, you can send me an email. We can talk about stuff, do screenshots, do all the biz. I will try my best to be as flexible as possible. Okay, these notes are also going to be available on the Canvas as I've worked them. Okay, these hard copies will be up there. So if you have any questions, guys, please feel free to give me a shout out. If not, I'm done. Thank you guys for watching. Okay, have a great, safe, and healthy day. And I continue blessings coming from me to you and to your families. Okay, thanks, Coach Friend out.